Let us start remaining part of chemical equilibrium. We are going to start a very interesting point, that is Le Chatelier principle. Le Chatelier principle state that when a system is subjected to change in concentration, temperature, pressure, then equilibrium adjusts itself so as to minimize the change made or cancel the change made. Very interesting statement. I will repeat the same. When a system is subjected to change in concentration, temperature, pressure, then equilibrium adjusts itself so as to minimize the change made or cancel the change made, that we called Le Chatelier principle. Now I will write in short that statement. When a system is subjected to change in concentration, temperature and pressure, then equilibrium adjusts itself so as to minimize or cancel the change made. To explain this term, consider again a very famous example. N2 plus thrice H2 gives twice NH3, formation of ammonia from nitrogen and hydrogen. Then system is subjected to change. This is said to be system is subjected to change in concentration. Means if we change the concentration of nitrogen or hydrogen, then what will happen? That change in concentration will shift the equilibrium towards product or ammonia. Means that change in concentration is used, nullify. For what purpose? To shift the equilibrium towards right hand side. Means that the change in concentration is minimized or cancelled. Now, if we consider the second, temperature, as you know, this is the exothermic reaction. Formation of ammonia is an exothermic reaction. Now, if we decrease the temperature of this system, then what will happen? The decrease in temperature means temperature is changed, decreased. Then equilibrium will shift towards product, means ammonia. Then what will happen then? That decrease in temperature, change in temperature is used to shift the equilibrium towards the right hand side. Is that change in temperature is minimized or cancel or nullify to shift the equilibrium towards the product side. Now if we consider now third factor, pressure. If we increase the pressure of this system, for example, if you consider this example, if we increase the pressure of the system, then what will happen? As soon as pressure increased, equilibrium shifted towards product side. Means that increase in pressure means change in pressure is used or nullify, to shift the equilibrium towards product side. That's why we have to say when a system is subjected to change in concentration, temperature, pressure, then equilibrium adjusts itself so as to minimize or cancel the change made. Now again we will explain in detail. If we considered first point to explain this Le Chatelier principle, effect of concentration. Effect of concentration, first factor. Now again consider that particular example, N2 plus thrice H2 gives twice NH3. Just I told you, if concentration of N2 or H2 increases, that increase in concentration will shift the equilibrium towards the product side. Means that increase in concentration, change in concentration is nullified, minimized or cancelled. For what purpose? To shift the equilibrium towards product side. Now in reverse language, if we increase the concentration of ammonia, increase in concentration of ammonia will shift the equilibrium in backward direction, means towards the reactant side. Means that increase in concentration of ammonia, change in concentration of ammonia is nullified, is minimized or cancelled. For what purpose? To shift the equilibrium towards reactant side. In this way, effect of concentration, right, on equilibrium. Now if we consider the second factor, effect of pressure. As already I told you, pressure affects the equilibrium of only gaseous reaction. Pressure affects the equilibrium of only gaseous reaction. Again we discuss second point, pressure has no effect on equilibrium of those gaseous reaction which takes place with no change in volume. No change in volume. And now third point we discussed, pressure affect the equilibrium of those gaseous reaction which takes place with change in volume. Change in volume. And to consider that change in volume, consider two examples. 1 volume of nitrogen combined with 3 volume of hydrogen gives 2 volume of ammonia. Now effect of pressure. If pressure of this system increases, then increase in pressure will shift the equilibrium toward that direction where volume decreases. Increase in pressure will shift the equilibrium toward that direction where volume is decreases. Then in this case, what will happen? If pressure of this system increases, then equilibrium shifted towards ammonia, towards product side. Means that increase in pressure, change in pressure is nullified, minimized or cancelled to shift the equilibrium towards ammonia. In reverse language, if we say pressure of the system decreases, again change but decreases, then decrease in pressure will shift the equilibrium towards reactant side, means towards N2 and H2. Means that decrease in pressure is nullified. For what purpose? To shift the equilibrium towards reactant side. If we consider one more example, PCl5 1 volume gives PCl3 plus Cl2. 1 volume gives 1 volume of PCl3, 1 volume of Cl2. Now if a pressure of the system increases, then what will happen? Equilibrium will shift toward that direction where volume decreases. Now right hand side, left hand side, volume decreases. Therefore equilibrium of this reaction will shift towards reactant side by increasing the pressure. Means that change in pressure, increase in pressure is nullified. For what purpose? To shift the equilibrium towards PCl5. In reverse language, if a pressure of this reaction decreases, that decrease in pressure will shift equilibrium toward that direction where volume increases. Means that decrease in pressure will shift the equilibrium towards PCl3 and Cl2, that is the product side. Means the decrease in pressure, change in pressure is nullify, minimize, cancel. For what purpose? To shift the equilibrium towards product side. In this way, effect of pressure. Now third factor, effect of temperature. Effect of temperature. Now if we consider again same example, N2 plus thrice H2 gives twice NH3 plus 100 kilojoule. Now listen carefully, forward reaction is exothermic reaction and backward reaction is endothermic reaction. Because 100 kilojoule heat is evolved during the formation of ammonia. Means formation of ammonia is exothermic. And while backward means decomposition of ammonia is endothermic, because this much amount of heat is absorbed. As we know, evolution of heat is exothermic and absorption of heat energy is endothermic. Means formation of ammonia is exothermic and while decomposition of ammonia is endothermic. Now to explain effect of temperature, already we discussed, if a temperature of the system increases, means increases, if we supply heat energy to the system, temperature of the system increases. And you know, heat supplied to the system means heat absorbed by the system, that we call which reaction? Endothermic reaction. Therefore we have to say increase in temperature favors the endothermic reaction. Means increase in temperature will shift the equilibrium toward that direction where endothermic reaction takes place. Therefore, listen carefully, as you know, decomposition of ammonia means backward reaction is endothermic. Therefore, if we increase the temperature of the system, then equilibrium will shift towards reactant side. Means that increase in temperature is nullified, cancelled, or is used to shift the equilibrium towards reactant side. Right? In reverse language, if we decrease the temperature, means heat evolved to the surrounding. Means heat evolved to the surrounding from the system, we call it which reaction? Exothermic reaction. And therefore, if a temperature of this system decreases, then equilibrium will shift towards product side, towards ammonia, as formation of ammonia is exothermic. Therefore, decrease in temperature is used, minimize or cancel. For what purpose? To shift the equilibrium towards ammonia. This is said to be Le Chatelier principle. What is the Le Chatelier principle? I will repeat the same. When a system is subjected to change in concentration, temperature and pressure, then equilibrium adjusts itself so as to minimize the change made or cancel the change made. And by taking this example, we explain effect of concentration, effect of pressure, and then effect of temperature. Right? I hope you are getting me, right? Le Chatelier principle. And Le Chatelier principle have so many applications. Now, if you consider first application, formation of ammonia in Haber's process. applications of a Le Chatelier principle. First application formation of ammonia. In Haber's process. Now our aim is to form ammonia in industry, right? Le Chatelier principle is used. Now therefore this is the first application. Considered this reaction N2 plus thrice H2 gives a twice NH3. Reaction is carried out in a closed vessel at 473 Kelvin, 473 Kelvin and 1 atmospheric pressure. Then how ammonia is formed in good yield in quick time? This principle is useful. If we considered first factor, concentration, now if concentrations of N2 or H2, nitrogen or hydrogen, increases, and as we know, increase in concentration will shift the equilibrium towards product side. Again, we discussed in law of mass action, rate is directly proportional to the concentration, right? As the concentration of a reactant increases, the rate of forward reaction increases. And therefore, we can say that if concentration of N2 or H2 increases, then equilibrium will shift towards ammonia and more amount of ammonia is obtained. Therefore, Le Chatelier principle is used, right? How? If concentration of N2 or H2 increases, then increase in concentration will shift the equilibrium towards ammonia product. Ammonia is a product, therefore more amount of product, more amount of ammonia is obtained. That's why our aim is fulfilled to give the more amount of ammonia by using Le Chatelier principle or by using the increasing concentration of N2 or H2. Then second factor, effect of temperature. As we know, N2 react with H2 to form ammonia with the evolution of 100 kilojoule. Just we discussed formation of ammonia is an exothermic reaction. Formation of ammonia is an exothermic reaction, and therefore according to Le Chatelier principle, if temperature changes, then equilibrium will shift towards left or right side. And as we know, decrease in temperature will shift the equilibrium toward that direction where exothermic reaction takes place. Because if heat energy is evolved from the system to the surrounding, then temperature of the system decreases. And evolution of heat energy is nothing but exothermic. Therefore, decrease in temperature favors the which reaction? Exothermic reaction. And as you know, formation of ammonia is exothermic reaction. Therefore, temperature we have to decrease or increase? Decrease. Means decrease in temperature of the system will shift the equilibrium towards the product, towards ammonia. As the formation of ammonia is exothermic. And more amount of ammonia is obtained. More amount of ammonia is obtained, right? By decreasing the temperature, because formation of ammonia is exothermic reaction. Now third, pressure. pressure. Now, one molecule of nitrogen means one volume, three molecules of hydrogen means three volume, two molecules of ammonia means two volume. Means total four volume get converted into two volume. What it indicate? Formation of ammonia takes place with decrease in volume. Decrease in volume. And as already we know, if pressure of the system increases, if pressure of the system increases, then equilibrium shifted toward that direction where volume decreases. Therefore, our aim is to form more amount of ammonia. Our aim is to form good amount of ammonia. Then we have to increase or decrease the pressure. We have to increase the pressure. And as the pressure of the system increases, equilibrium shifted towards ammonia, because formation of ammonia takes place with decrease in volume. How we can say decrease in volume? Because four volume get converted into two volume, right? Therefore, conclusion: if pressure increases, equilibrium shifted towards ammonia and more amount of ammonia is obtained, right? Means these three factors are used to form more amount of ammonia in quick time. This is the first application of Le-Chatelier principle. I will repeat the same in short. First application, formation of ammonia in Haber's process, and for that we consider N2 react with thrice H2 gives twice NH3 plus 100 kilojoule. This reaction is carried out at 473 Kelvin and under 1 atmospheric pressure. Then we consider first factor, concentration. As the concentration of N2 or H2 increases, then equilibrium shifted towards ammonia and more amount of ammonia is obtained. When pointing arrow in upward direction, increases, right? This is the first factor. Now second, temperature. As the formation of ammonia is exothermic, as formation of ammonia is exothermic reaction. Therefore, as the temperature of this reaction decreases, then equilibrium shifted towards ammonia and more amount of ammonia is obtained, because decrease in temperature favors the exothermic reaction. Third factor, pressure. Total 4 volume get converted into 2 volume, means we have to say formation of ammonia takes place with decrease in volume. Decrease, downward arrow indicate decrease in volume. Therefore, we have to increase or decrease the pressure. Increase the pressure, because increase in pressure will shift the equilibrium toward that direction where volume decreases, and therefore as pressure increases, equilibrium shifted towards NH3 and more amount of ammonia is obtained. I hope You are getting me. First application of Le Chatelier principle, that is a formation of ammonia. Formation of ammonia. Now, second application. Second application, formation of NO, that is Berkelandite process. Berkelandite process. Consider that example N2 plus O2 gives twice NO minus 288 kilojoule. One volume react with one volume of oxygen gives two volume of NO. First, if we consider the effect of concentration. Simple point. As the concentration of N2 or O2 increases, then equilibrium shifted towards NO and more amount of NO is obtained. Again, we know law of mass action. Rate is directly proportional to the concentration. As concentration increases, rate increases. And therefore, by increasing the concentration of N2 or O2 will shift the equilibrium towards NO and more amount of NO is obtained. Therefore, write in short as concentration of N2 or O2 increases, then equilibrium shifted towards ammonia and more amount of ammonia is obtained. More amount of ammonia is obtained. Second factor, effect of temperature. As we know, minus sign. Already we discussed absorbed heat is shown in an equation on right hand side with negative sign. And you know, absorption of heat is which reaction? Endothermic reaction. And this minus sign indicates absorption of heat. Therefore, formation of NO is endothermic reaction. Therefore, our aim is to form NO in good yield or in good amount. Therefore, we have to increase or decrease the temperature. We have to increase the temperature. Therefore, if a temperature of this reaction increases, then equilibrium will shift toward that direction where endothermic reaction takes place. And as formation of NO is endothermic, and therefore increase in temperature will shift the equilibrium towards product, that is a NO, and more amount of NO is obtained. Therefore, our aim is fulfilled to form more amount of ammonia by increasing the temperature. Therefore, we write as temperature of this reaction increases. Then equilibrium shifted towards, sorry here, we correct that, towards NO. Towards NO, and as equilibrium shifted towards NO, more amount of NO is obtained. More amount of NO is obtained by increasing the temperature. Right? Now, third factor, effect of pressure. As you know, pressure affect the equilibrium of only gaseous reaction. Again, we know one more point. Pressure has no effect on those gaseous reaction which takes place with no change in volume. Right? I repeat the same. Pressure has no effect on those gaseous reaction which takes place with no change in volume. Now concentrate your eyes on this reaction. On reactant side, one molecule of nitrogen means one volume, one molecule of oxygen means one volume, means total 2 volume of reactant gets converted into 2 molecules of NO means 2 volume. Therefore, 2 volume of reactant get converted into 2 volume of product, means there is no change in volume, and therefore here pressure has no effect. Pressure has no effect of such reaction, right, which takes place with no change in volume, right, and therefore here this factor is not applicable. Third factor is not applicable, that is effect of pressure. I hope you are getting me, right? I will repeat the same in short now. Second application, formation of NO, that is Birkeland-Eyde process. And for that we considered N2 plus O2 use twice NO minus 288 kilojoule. Minus means endothermic reaction. Total 2 volume get converted into 2 volume. First factor, effect of concentration. As the concentration of N2 or O2 increases, then equilibrium shifted towards product side, means towards NO, and more amount of NO is obtained. More amount of NO is obtained. Now, second factor, effect of temperature. As the formation of NO is endothermic reaction, formation of ammonia is endothermic reaction. Therefore, increase in temperature will shift toward that direction where endothermic reaction takes place, and that's why by increasing the temperature of this reaction will shift the equilibrium towards NO, and more amount of NO is obtained. Right? Now then third factor, effect of pressure. Pressure affects the equilibrium of only gaseous reaction. That is the main point. Again, sub point, pressure has no effect on those gaseous reaction which takes place with no change in volume. Here 2 volume get converted into 2 volume, in this reaction takes place with no change in volume. Therefore, pressure has no effect on this particular reaction. These are the 2 applications of Le-Chatelier principle. First, formation of ammonia in Haber's process, and second, formation of NO in Birkeland-Eyde process. I hope you are getting me. Yes, thank you.